Hey everybody, this is Mr. Longo, and in this video we are going to introduce you to some popular 3D figures that we're going to be working with in this surface area and volume unit. So the first one we'll talk about is a prism. Now a prism I know you've seen before. You're probably thinking of the little piece of glass that creates rainbows, but a prism is basically any three-dimensional figure that has polygons for bases. So before we talk about what a base is, when you have these figures, you name it by its base. So this would be a rectangular prism. This one would be a triangular prism. So the bases are the non-rectangular faces of any prism. The only way that it's different is if they're all rectangles. Then, to be honest with you, you can select any one of the faces to be your base. So, I'm just going to pick the top and bottom because they look similar to a square. And I'm going to pick the triangle because on this prism to the right here, you have no choice but to select the triangles for your bases. Okay? Now, an interesting piece of information is the height. The height is not always vertical. So if you look at this prism, it's standing up and down. So our height is from top to bottom, but the height is the distance between the bases. For example, you're 5'6", but when you're laying down, your height doesn't change. So this prism, the height is actually the distance between the two bases. It's front to back for this picture, okay? So, the other things you need to know are all of the rectangles that connect the bases. Those are called your lateral faces. Okay, so if I were to just highlight one of these things, that would be your lateral face. So when you're finding the area of all of the lateral sides, we call that the lateral area. And then, of course, you have your area of the base. When we get to surface area, you're going to basically add everything up, and that'll be your total surface area. But for right now, we're just talking about the parts of 3D figures. Other things that might be helpful to know is where your edges intersect. Those are called vertices. And of course, the straight lines are your edges. So now you know some terminology. A pyramid. A pyramid is not a prism because a prism has two bases. A pyramid only has one. Now, you can have all sorts of different kinds of pyramids. We're not simply thinking about the ones in Egypt. You can have pyramids with a square base. You can have pyramids with a hexagon base or a pentagon base. There's all sorts of different kinds of pyramids. But the key is that they only have one base. But they have two different heights, and it's extremely important that you know the difference here. So, again, we know that this bottom is going to be our base. But one of your heights is the actual height of the pyramid. So, how tall this pyramid is from the bottom to the top. So that's from the vertex to the center of your base. Now there's another height that we call a slanted height, which is L. So L is your slanted height, but really it's just the height of the triangular face. So in a prism, I said we have all rectangular faces. Well, in a pyramid, all of your faces are triangles. So we know that when we're finding the area of a triangle, it's half the base times height, but we can't have two different heights in a pyramid doing the same thing. So that's why we have different ones. We have L for slant height and H for the actual height of the pyramid. Okay? Now, the next ones are circular 3D figures. And when it comes to a cylinder, cone, and a sphere, the one thing that they always have in common is the fact that you need the radius. Okay, but since it's a circle, the radius is Yeah, half the diameter. You could also use the diameter. Either one that's given are interchangeable. If you're given a diameter, half of it's the radius. If you're giving the radius and you need the diameter, you double it. So we've already completed our circles unit. That's no big deal. So, the different things. In a cylinder, just like a prism, the height is the distance between the bases. Now, in a cylinder, cone, those will always be circles. Your base shape will always be circles. So the height is the distance between your circles. Just like in a pyramid, you have two different types of heights in a cone. You have your actual height of the cone. That's the inside height from the top or our vertex to the center of the circle base. And we also have the slanted height again. Now, when you guys are thinking about the lateral areas of cylinders and cones, sometimes it's a little tricky to think about it, but what it really is in a cone, in a way, it's kind of like a triangle. Because if you were to unwrap that, it would look like a triangle that had a rounded base. And every one of you has probably peeled the label off of a bottle or something cylinder. And when you unroll it, you have a rectangle, which would be the height. Now this would be the circumference. Okay, the width of your rectangle once you undid it would be the circumference of your cylinder. And finally, last but not least, we have the sphere. The only thing you're going to need for a sphere is the radius, and we're going to work with all of that a little later as well. Now, one thing that you could say is these circular figures are actually formed by transformations by rotating around an axis. So if you were to take an axis and draw a rectangle and just spin it around in circles really, really fast, it would look like this. And then you can see that rotating a rectangle around an axis is going to create a cylinder. If you were to take a triangle and rotate it around an axis really, really fast, the shape you would see would be a cone. And then finally, the sphere. I'm guessing you can already decide that you're just rotating a circle around an axis really, really fast. And if you spin that, you're going to have a sphere. Okay, so that's your introduction to 3D figures. This is Longo, and I'm out. See you, bye.